everyone, I'm Amit Kashri Premdas.
I'm Bharati Ravindran. I'm Elena Resha Sinampan. I'm Rashika Deva Ranganathan.
And I'm Devendra Saravanan.
We are from Sjkt Jalan, Haji, Manan. The title of our experiment is The Effect of Mass on Speed of an Object. Now, let us explore our team's experiment. Mass, quantitative measure of inertia, a fundamental property of all matter. It is in effect the resistance that a body of matter offers to a change in its speed or position upon the application of a force. Speed can be thought of as the rate at which an object covers distance. A fast-moving object has a high amount of speed and covers a relatively large amount of distance in the time given. However, a slow-moving object has a low amount of speed and covers a relatively small distance in the same time given. In our experiment, we controlled the distance travelled by the model truck and measured the time taken to travel. From that, we calculated the speed. Meanwhile, we changed the mass of the model truck and to differ the speed.
The problem statement for our experiment is: how does the mass of the model truck affect by speed to travel 200 cm? The control variables for our experiments are the size of the model truck, the distance travelled by the model truck 200 cm, the type of the model truck, the surface of the plank, the height of the plank, the same type of curtain ray. The manipulative variable for this experiment is the mass of the model truck. The responding variable for our experiment is the speed of the model truck. Materials needed are model truck, plywood, weight 20 grams per piece, curtain ray, sandpaper, cardboard and adhesive tape. Apparatus needed are stopwatch, chalk, measuring tape, calculator, weighing scale and scissors. Steps of the experiment. Before conducting the experiment, we designed a track for the model truck to travel with the help of teachers. Step 1. The model truck was placed on the plank. Step 2. The model truck was released from the starting point. Step 3. The time taken to travel by the model truck was taken simultaneously. 1, 2, 3. Step 4. The time was calculated and noted in the table after the model truck reached the ending point. 4 seconds and 38 milliseconds. Next, the steps from 1 to 4 were repeated by increasing the load to 100 grams, 300 grams and 600 grams. Next, the steps were repeated 5 times for each load. 100 grams. 1, 2, 3, 4. 4.50. Second time with 100 grams. 1, 2, 3, 4. Fifth time with 100 grams. 1, 2, 3, 4. 100 grams. 200 grams. 300 grams. 1, 2, 3, 4. 3.44. Second time with 300 grams. 1, 2, 3, 4. Fifth time with 300 grams. 1, 2, 3, go. 100 gram, 200 gram, 300 gram, 400 gram, 500 gram, and 600 gram. 1, 2, 3, go.
2.97.
Second time with 600 gram.
1, 2, 3, 4.
Fifth time with 600 gram.
1, 2, 3, go. The average reading were calculated. 0 gram, 5.886. For 100 gram, 3.904. Next, for 300 gram, 3.308. For 600 gram, 3.168. The speed were calculated and noted in the table. We use speed formula to calculate. Speed equals to distance divided by time. 0 gram, 33.97. 100 gram, 51.22. 300 gram, 60.49. 600 gram, 63.09. Conclusion: when the mass of the weight increases, the speed of the model truck will also increases. When the mass of the model truck decreases, the speed of the model truck will also decreases.
From the result, our hypothesis is accepted. The heavier object has more speed when traveling through the ramp. Discussion: mass doesn't affect speed directly. It determines how quickly an object can change speed, accelerate under the action of given force. The mass we added in the model truck created a pushing force and made the model truck move forward in high speed. Galileo discovered that objects that are more dense or more mass fall at a faster rate than the less dense object. Due to this air resistance, weight affects speed down the ramp, the pull of gravity. But it's the mass that affects speed after a truck leaves the ramp. Heavier trucks have more momentum, so they travel in high speed. Now let me tell you the safety precautions. Sanitize all of the apparatus and material. Wear mask during the experiment. Handle the scissor carefully. Handle the model truck safely and carefully. Handle the kitchen scale carefully.
From the result, we created a graph. When the weight is 0 gram, the speed of the model truck is 33.97 centimeter per second. Compared to the weight 600 gram, the speed increased to 63.09 centimeter per second. From the graph, we learned that the more the mass, the more the speed of the model truck.
Go.
What is the relationship between momentum and mass?
Mass and velocity are both directly proportional to the momentum. If you increase either mass or velocity, the momentum of the object increases proportionally. If you double the mass or velocity, you double the momentum. In daily life, we can see that a lorry with heavy load finds difficulty to travel on hill, but it will move faster towards down the hill. It's because the momentum
Very good.
Find difficulty.
Stop suddenly.